You're probably not gonna believe this, but what if I told you that scientists found this skull in 1912 and were like, holy shit, we just found the missing link between apes and humans. Except it was literally just some medieval dude's head glued to an orangutan's jaw, and nobody figured that out for over 40 years. These are a ton of different prehistoric animals that scientists and us got completely wrong throughout history. Let's start with that fossil, the Piltdown Man. Charles Dawson shows up with these bone fragments from England, right? And the scientific community just loses their minds. They're calling it Eonthropus dawsoni, which sounds super official and sciencey, but it's basically naming a hoax after yourself. That is some next level confidence right there. The best part, this thing had a human skull with an ape jaw. It's not even a good fake. Someone literally took an orangutan jaw, filed down the teeth so that they looked more human, stained everything brown so it looked old, and buried it. Then they probably sat back and watched grown adults with PhDs get excited about finding their ancestors. These weren't just random people getting fooled either. They were the top paleontologists in the world. They put this thing in textbooks. Museums displayed it for 4 decades. Kids learned about the Piltdown Man in school. Meanwhile, real human ancestor fossils from Africa were getting ignored because they didn't have big enough brains to match what Piltdown was showing. The whole thing fell apart in 1953 when better testing came along. Turns out the skull was medieval. The jaw was from a modern orangutan, and whoever made it wasn't even trying that hard. The teeth had obvious file marks. The bones were stained with paint and chemicals you could buy at any hardware store. And here's what gets me. It took 41 years for anyone to really question whether a skull and jaw that clearly didn't belong together might be suspicious. This is the fearsome Corgosaurus Rex. His name is Flapjack. And if you don't like and subscribe, he literally is going to eat you. Look at his face. This is a fearsome apex predator from the prehistoric period. You don't want to mess with him. But one pig tooth somehow convinced people an entire species existed. Harold Cook found this single tooth in Nebraska in 1922. One tooth. And Henry Osborn, who's supposed to be this brilliant paleontologist, took one look at it and declares that they've found Hesperornithopithecus Haroldon Cookie, Nebraska's very own ape man. Now, I've seen people make bad decisions based on limited information, but building an entire human species around one tooth is pretty bold. That is some serious scientific confidence right there. Osborn didn't just say, hey, interesting tooth. He straight up announced to the world that America had its own human ancestors. The media went absolutely insane. The Illustrated London News published a full drawing of Nebraska Man and his wife just hanging out on the prairies. They gave this guy a whole family based on nothing. Some artist had to sit down and draw what he thought an ape man's wife would look like, knowing the only evidence was a single molar. That's gotta be the weirdest art commission in history. People bought into this completely. Nebraska Man became America's answer to all of those European and African fossils. Finally, the United States had its own piece of human evolution, except for the part where it was complete nonsense. 5 years later, they found more bones from the same site. Turns out that famous tooth belonged to Prostonopops, an ancient pig. Not just any pig, but a pig that had been dead for millions of years before humans even existed. So Nebraska Man went from humanity's ancestor to pork chop in about as much time as it takes to get through college. Osborn had to publish a retraction admitting he declared an entire human species based on a pig tooth. The scientific community quietly moved on, probably hoping nobody would bring it up at future conferences. The tooth is still around somewhere, probably laughing at all of us. But now let's move on to Megalonyx. Thomas Jefferson got some massive claw bones mailed to him in 1796. We're talking about claws the size of your forearm here. And Jefferson, being Jefferson, immediately decides this has to be some kind of giant lion that's probably still wandering around Virginia somewhere. He names this thing Megalonyx, which means great claw, presents his findings to the American Philosophical Society. Keep in mind, this is the guy who's about to become president, standing up in front of serious scientists and basically saying, I found evidence of American super lions and they might still be alive. Jefferson was dealing with some serious national pride issues at the time. Europeans kept saying American animals were smaller than old world creatures. So when he finds these enormous claws, he's thinking, finally, America's got its own giant predator. He even sent Lewis and Clark out west, partially hoping they'd run into one of these monster cats. The whole thing gets even better when you realize Jefferson was working with almost nothing. 3 claw bones and some leg fragments. That's it, but he's out here writing papers about American lions and getting genuinely excited about the possibility that explorers might find living ones in uncharted territory. Then in 1797, word gets back to him about this thing called Megatherium, a giant sloth from South America that Cuvier had been studying. Jefferson takes one look at the drawings and realizes his great American lion is actually a vegetarian and probably moved about as fast as a refrigerator if it had legs. He had to backtrack pretty quickly on the whole fierce predator angle. Turns out his monster was just a really big plant eater with claws for pulling down tree branches. The claws weren't for slashing prey, they were for reaching lunch. And speaking of bones that cause major confusion about diet choices, let's talk about the American Mastodon. People kept digging up these huge teeth in places like Kentucky, and everyone's first thought was, well, those are definitely from some kind of flesh-eating monster, right? The teeth had these big pointy bumps all over them, which seemed pretty obvious. Pointy teeth eat meat, right? George Washington himself looked at mastodon teeth. Ben Franklin wrote letters about them. These were smart guys, and they all came to the same conclusion. America had been home to carnivorous giants that could probably eat a horse for breakfast. The teeth really did look weird compared to anything people knew about. Elephant teeth are flat and rigid for grinding plants. These mastodon teeth looked more aggressive, with high cone-shaped cusps that seemed designed for crushing bones and tearing flesh. George Cuvier finally showed up in 1806 and had to explain to everyone that they'd been wrong for decades. Those scary-looking teeth, they were perfect for chewing up tough tree branches and bark. The high, bumpy cusps weren't for slicing meat. They were for grinding woody stuff that regular flat teeth couldn't handle. But the carnivore idea had gotten so popular that museums were mounting mastodon skeletons with their tusks pointing downward, thinking they used them to spear prey, which they had to fix too. Mastodon tusks were curved up for digging and display, not down for stabbing things. The whole mix-up happened because people applied simple logic. Sharp equals predator. Nobody considered that some plant eaters might need heavy-duty teeth for processing tough vegetation. Mastodons were basically shaggy forest elephants that specialized in eating the prehistoric equivalent of tree bark and twigs. All of those years of imagining fearsome American carnivores, and it turns out they were really just big vegetarians with impressive teeth. Sometimes the scariest looking mouth just wants to eat a salad. But now picture finding fossil pieces that look exactly like fish fins. So you call it the winged fish, except those fins were actually the grabbing claws of an 8-foot-long sea scorpion that could probably bench press a medieval knight. Louis Agassiz gets these fossil fragments in 1839 and does what any reasonable person would do. Assumes they're from some kind of massive fish. The pieces were broad and flat. They had these spine-like edges, and fish were pretty much the only giant water animals anyone knew about back then. So Pterygotus becomes the winged one, presumably because someone thought those flat pieces looked like impressive fins. This went on for about 5 years. Museums probably had displays talking about this mysterious giant fish from the ancient seas. Maybe some artists drew pictures of it swimming around eating smaller fish. The whole scientific community just accepted that Scotland used to have some seriously oversized aquatic life. Then in 1844, more complete fossils show up and everyone realizes they've been completely wrong about what they were looking at. Those fish fins were actually the business end of enormous claws attached to what amounts to a lobster the size of a canoe. But Pterygotus wasn't swimming around peacefully eating algae. It was hunting with compound eyes the size of dinner plates and grabbing prey with claws that could probably crack open a treasure chest. This thing was the apex predator of its time, cruising around Devonian waters looking for something to grab and presumably ruin the day of. The name stuck though, so we're still calling it the winged one, even though we know those wings were actually nightmare fuel attached to an arthropod that makes modern lobsters look like a house cat. But at least that mistake took years to figure out, unlike the next creature we're going to be talking about. So scientists find this fossil in 2015. They see 4 tiny legs on what looks like a snake's body, and immediately they declare that they've found the holy grail of evolution, a snake that still had its arms and legs. The internet obviously loses its collective mind. Headlines everywhere are screaming about the missing link between snakes and lizards. News articles are calling it one of the biggest discoveries in paleontology. Social media is going crazy with people sharing pictures of this 4-legged snake, and talking about how amazing evolution is. Museums start planning exhibits. Scientists start writing papers about how this proves snakes used to have limbs before they evolved them away. The whole thing becomes this poster child for evolutionary theory in action. The problem is, nobody really stopped to double check whether this thing was actually a snake in the first place. Fast forward to 2021 and a different team takes another look at the same fossil. Turns out the skull shape is wrong for a snake. The vertebrae don't match up right either. The tail's got the wrong proportions. Basically everything about this snake suggests it's not a snake at all. What they actually found was a dolichosaur, which is just a regular lizard that happened to be really long and lived in marine environments. These lizards evolved elongated bodies for swimming around in ancient seas, which has nothing to do with snake evolution whatsoever. So the revolutionary four-legged snake becomes totally normal lizard that coincidentally looks snake-like. The missing link disappears and all of those excited headlines become slightly embarrassing. The whole discovery goes from groundbreaking to a footnote in about 6 years. Sometimes the most exciting scientific breakthrough is just wishful thinking with a press release attached. But let's fast forward to 1983 because Science magazine puts this thing on their cover during this year. It shows a furry, crocodile-shaped creature diving headfirst into a river, presumably hunting fish. It looks pretty convincing, right? Primitive whale ancestor doing primitive whale things in the water. Except Pakicetus was basically just a wolf that occasionally got its paws wet. The whole reconstruction came from finding a partial skull in Pakistan, just the back part and some jaw pieces. But since everyone knew this was supposed to be an early whale, they filled in the blanks with what seemed obvious. It must be amphibious, and it probably spent a lot of time swimming and definitely hunts in the water. Artists gave it webbed feet and made the tail thick for swimming. They put it in rivers chasing after fish. The thing looked ready to compete in the Olympics for prehistoric diving. Museums probably had displays talking about the amazing transition from land to sea. Then, in 2001, they find the rest of the skeleton. Long legs, normal feet, and body proportions that scream, "I run around on dry land for a living." The limb bones looked exactly like what you'd expect from a terrestrial carnivore, not a swimming animal. Turns out Pakicetus lived near water the same way a lot of predators do, because that's where prey hangs out. It might wade in to grab a fish now and then, but calling it aquatic would be stretching it. This would be like calling a bear aquatic. That is not a fish, that is a bear. So that dramatic magazine cover of a diving proto whale becomes a picture of what's essentially a dog jumping into a creek. Still technically accurate, but it's way less impressive than the original story suggested. But moving on, let's talk about the time when Cuvier once mistook horse claws for giant anteater parts. George Cuvier finds this massive claw bone in 1825 and thinks, well, obviously this belonged to some kind of giant pangolin, because when you're looking at enormous claws, pangolin seems reasonable. They dig into termite mounds with their claws, so bigger claws just means bigger termite mounds. Wrong, but you can see the logic. Then other scientists get involved and decide that anything with claws that big has to be a predator, which makes sense on paper. Big sharp claws usually means something gets ripped apart for dinner. So Chalicotherium briefly becomes this terrifying carnivorous beast stalking around ancient Europe. Meanwhile, the actual Chalicotherium was probably the most peaceful thing in its entire ecosystem. Those scary claws were for hooking tree branches and stripping leaves. It was essentially a horse that traded hooves for garden tools. The predator idea fell apart pretty quickly once people looked at its teeth. It had flat, grinding molars, which were perfect for chewing plants and terrible for slicing meat. It's hard to maintain your reputation as a fearsome killer when your mouth is clearly designed for eating a salad. But the pangolin mistake hung around longer because nobody had enough bones to figure out what Chalicotherium actually was. They just had this one weird claw that didn't match anything they knew about. Cuvier's guess made as much sense as everything else at the time. Finally though, more complete skeletons show up and reveal the truth. Chalicotherium was related to horses and rhinos. It just happened to evolve the world's most inconvenient feeding strategy. Instead of grazing on ground-level plants, it developed these massive claws to pull high branches down to mouth level. Moving on, let's talk about the time Australian museums literally burned their Palorchestes statue in the ground to avoid admitting that they got it wrong. They just dug a hole and covered up their giant kangaroo model rather than face the embarrassment. Richard Owen started this whole mess in 1873. He finds some jaw pieces, sees teeth that kind of look kangaroo-ish, and decides Australia had giant hopping marsupials. He names this thing Palorchestes, which means ancient leaper, and everyone just rolls with it. For decades, museums displayed these massive kangaroo models. Kids grew up learning about prehistoric Australia filled with wallabies the size of cars. Scientists wrote papers on how these giant hoppers ate a bunch of ancient shrubs. The whole narrative fit perfectly. Australia has always had weird hopping things, so why not really big weird hopping things? Nobody questioned though why a giant kangaroo would need such a weird skull shape, or why the jaw structure looks so different from modern kangaroos. Owen had found a new bone fragment and everyone filled in the rest with pure imagination. Then in the 1950s, more complete fossils show up. Suddenly it gets really obvious that Palorchestes couldn't hop if its life depended on it. The skull had retracted nasal bones, suggesting a short trunk. The limbs were built for walking on all fours, not bouncing around. The whole body plan screamed slow-moving browser with grabbing nose, not ancient kangaroo. So Australia's giant leaper becomes a marsupial tapir that probably used its trunk to strip leaves off trees. The name ancient hopper now sounds ridiculous attached to something that moved about as athletically as a filing cabinet. But meanwhile, Scotland's tiniest fossil got mistaken for baby Godzilla. 20 centimeters long, which is barely bigger than your phone, but scientists took one look at this tiny Scottish fossil and declared it a miniature dinosaur. Someone saw those little leg bones and thought clearly this is what T-Rex looked like as a baby. The fossil came from 1907, back when paleontology was still figuring out what belonged where in the reptile family tree. Scleromochlus had long hind legs and short front ones, which seemed pretty dinosaur-like at the time. Plus, it was from the Triassic period, right when dinosaurs were getting started. So textbooks started featuring this pocket-sized proto-dinosaur hopping around ancient Scotland. Artists drew it running on two legs, maybe chasing insects or hiding from bigger predators. Museums probably had displays talking about how even the mightiest dinosaurs started small. The identification made sense given what people knew back then. Dinosaurs were bipedal. This thing looked bipedal. Dinosaurs had certain ankle features. This thing had similar ankle features, which was close enough for 1907 paleontology standards. But by 2020, better imaging technology reveals that Scleromochlus belongs nowhere near the dinosaur family tree. Those ankle bones and skull features actually line up with Pterosaurs, the flying reptiles that wouldn't evolve wings for millions of years. So this tiny groundhopper turns out to be related to creatures that would eventually rule the skies. Not a baby T-Rex, just a distant cousin of pterodactyls that preferred jumping around on the ground to soaring through the air. This correction changed our understanding of how pterosaurs evolved. Turns out their ancestors weren't mysterious flying creatures that appeared out of nowhere. They were little bouncing reptiles that looked nothing like what they'd eventually become. Sometimes the smallest fossils cause the biggest headaches though. Now let's talk about Hyracotherium. Richard Owen names the first horse fossil after a hyrax. Not just any hyrax, a rock hyrax, which looks about as much like a horse as a hamster looks to a giraffe. This happens in 1841 when Owen gets some tiny teeth and jaw pieces from England. The teeth are small and bumpy, which are nothing like the flat grinding teeth of modern horses. So he looks around for something similar and settles on hyrax molars. Close enough, right? And he names it Hyracotherium, meaning hyrax beast, and files it away under small rabbit-ish thing. For decades, nobody connects these little fossils to horses at all. Why would they? Horses are big, single-toed, long-faced grass eaters. These fossils came from something the size of a fox terrier with 4 toes and teeth for eating soft leaves. But meanwhile, in America, Nathaniel Marsh finds similar fossils in the 1870s and calls them Eohippus, which means dawn horse. He recognizes them as early horses because he's got more complete skeletons and can see the family resemblance. But Owen's name came first, so scientifically it wins. That's just how it works. So now we've got this awkward situation where the first horse is officially called Hyrax Beast, even though it has nothing to do with hyraxes. Owen's mistake is literally written into the scientific name forever. Modern horse evolution textbooks have to explain this embarrassing bit of taxonomic history. Every time someone studies early horses, they have to use a name that celebrates getting it completely wrong. And here is the really funny part. Hyraxes are actually more closely related to elephants than to horses, so Owen managed to name a horse ancestor after something from an entirely different branch of the mammal family tree. That has got to be some kind of record for missing the mark. But flying reptiles got even weirder treatment from confused scientists. The first guy to study a pterosaur decides it must be some kind of swimming animal. They look at those wing membranes and think obviously these are flippers for paddling around underwater, because apparently the idea of a flying reptile was too ridiculous to consider at the time. Cosimo Collini gets the first pterosaur fossil in 1784 and spends years trying to figure out what he's looking at. The wing membranes are preserved, the long finger bones are there. Anything you would need to see to think flying animal is right in front of him, but flying reptiles don't exist, so it must be aquatic. It takes George Cuvier to show up in 1801 and point out that maybe, just maybe, this thing could fly. It's a revolutionary concept apparently, but even after people accept that pterosaurs flew, the mistakes keep coming. Edward Newen looks at some pterosaur fossils in 1843 and notices what looks like hair fibers. His brilliant conclusion: they must be warm-blooded flying marsupials with pouches for carrying babies. Newman publishes papers arguing that pterodactyls are basically giant bats with kangaroo pouches, and draws pictures of furry pterosaurs carrying their young around while soaring through Mesozoic skies. The whole thing reads like someone's fever dream about evolution. Marsupial idea sticks around for a while because people are still figuring out what warm blood means and how to tell mammals apart from fish. Plus, those hair-like fibers are real. We now know pterosaurs had fuzzy insulation called cynofibers. Eventually though, everyone realizes pterosaurs are reptiles that independently evolved flight, warm blood, and fuzzy covering. Not fish, not marsupials, just really weird reptiles that happen to figure out how to fly before the birds did. Yeah, sometimes the simplest explanation takes the longest to accept. Now let's move on to another animal. Imagine an elephant with a snow shovel duct taped to its face, squatting in a swamp and scooping up weeds. Well, that's what scientists thought Platybelodon looked for the most of the 20th century. This thing had the weirdest jaw in mammal history. The lower part was stretched out flat and wide, ending in two massive tusks that looked ready to dig a foundation. Henry Osborne looked at this setup in the 1930s and he thought, obviously this is swamp equipment. The logic seemed bulletproof. Flat tusks must be for scooping, right? So Platybelodon becomes this aquatic plant harvester, standing knee-deep in ancient marshes and literally shoveling a vegetation into its mouth. Museum displays showed it dredging pond bottoms. Textbooks called it the shovel-tusked elephant and described its backhoe lifestyle. Artists drew these things squatting by water, using their tusks to scrape up roots and water plants. Some reconstructions even had them propped up on their hind legs to get better scooping angles. The whole image was weirdly industrial. It was basically a prehistoric construction worker with trunks. But in the 1990s, somebody finally looked at the wear patterns on those shovel tusks under a microscope. Instead of the smooth polish you'd expect from scraping mud, they found deep scratches and heavy abrasion. This is the kind of damage you would get from cutting through tough woody material. So Platybelodon wasn't dredging swamps at all. It was using those flat tusks to slice through bark and tough plant stems on dry land. It was more like a hedge trimmer than a shovel. The swamp elephant was actually a land browser that happened to have evolution's strangest set of pruning shears. So all of those museum displays of mud-wallowing behemoths had to get quietly updated to show a terrestrial plant cutter instead. But giant sloths got equally ridiculous makeovers from an over-eager paleontologist. Paleontologists looked at giant sloth skulls and decided that they needed trunks. Not little trunks either. They needed full elephant-style proboscises for grabbing tree branches. The reasoning made sense at a first glance. Megatherium had these massive nasal openings in its skull, which were way bigger than modern sloths. Big nose holes mean big nose, right? So 19th century reconstructions gave these ground sloths elephant-like trunks for reaching high foliage. Artists went wild with the concept and drew Megatherium standing upright, using muscular trunks to pull down branches, while tiny tree sloths watched in amazement. Some illustrations made it look more elephant than sloth. The trunk became this thing's defining feature in popular imagination. Museums went on to build models with prominent proboscises. Natural history books featured trunk-wielding giant sloths as examples of prehistoric diversity. For decades, people learned that South America used to have these elephant-sloth hybrids wandering around grabbing leaves with their flexible noses. The problem was, no one bothered checking whether sloth relatives actually developed trunks. Anteaters have long snouts, sure, but muscular grabbing trunks are pretty much an elephant thing. And when you look at where Megatherium's nostrils actually opened, they're at the front of the snout, not pulled back towards the skull like an elephant's nostrils. By the late 1800s, Bester fossil analysis killed the trunk idea. Those big nasal cavities probably just housed a large, fleshy upper lip, maybe slightly prehensile for grabbing, but nothing approaching an actual trunk. It's more like a black rhino's grabbing lip than an elephant's nose. So Megatherium went from trunk-wielding tree grabber to just a really big sloth with strong lips. Still impressive, but way less exotic than those early Victorian reconstructions suggested. But ultimately, marine reptiles faced one of the strangest makeovers of them all when scientists got them completely wrong. Victorian England once built these massive concrete sculptures of Mosasaurus at Crystal Palace in the 1850s. It depicted them as fat, newt-shaped creatures with tiny flippers lounging around like oversized salamanders. Tourists can still visit these sculptures today and see exactly how wrong 19th century paleontology could get. This mistake started with incomplete fossils. Early Mosasaurus finds were mostly skull pieces and vertebrae, nothing that clearly showed how the tail worked or what the body actually looked like. So scientists filled in the gaps with their best guesses. Since Mosasaurus was obviously a marine reptile, they figured it probably swam by wiggling its body side to side, snake style. It made sense given what they knew about big swimming reptiles at the time. Sea snakes move that way, so why not giant extinct lizards? Artists drew Mosasaurus as this enormous eel thing, undulating through Cretaceous seas with its long body doing all the work. Some early reconstructions even put the nostrils on top of its head, thinking its surface to breathe like a whale. The Crystal Palace models went full salamander though, with broad, flat bodies perfect for belly crawling through ancient swamps. They literally look like a fat crocodile. But by the late 20th century, more complete skeletons revealed something completely different. Mosasaurus had a massive two-lobed tail fin, which was basically a shark tail attached to a lizard. Its body was streamlined for power swimming, not eel wiggling. The thing moved like a reptilian orca, using that tail to generate serious thrust. Those Victorian sculptures now look ridiculous next to modern reconstructions. Look at this thing. It just looks like a chubby lizard. Instead of a chubby swamp lounger, we see sleek marine predators that could probably catch up to a speedboat. The nostrils stayed on the sides of the snout where they belonged, and the whole body plan screamed apex predator now, not oversized pawn newt who had too much to eat at Thanksgiving. And those are just a couple of the prehistoric creatures that we have gotten wrong as we've developed paleontology. It's really interesting to see what people thought 100 years ago and what we know now today. How many dinosaurs do we think we know today that will be completely different in 100 years? It's a really exciting thing to think about, honestly. Anyways, if you enjoyed watching this video, make sure to give it a like, subscribe to the channel for more videos just like this too, and feel free to give this video some hype. If you're on mobile, just scroll down and you'll see the hype button. It's one of the best ways to get your favorite creators seen by more new viewers. Comment down below any other dinosaurs scientists have gotten wrong you would like me to talk about, as I've made a few videos just like this now. And if you'd like to watch another one of these videos, you can click the video on screen now.